Hello, and welcome to Julia Programming with the Data Scientist. My name is Dr. Randy Davila, and today we're talking about the Palmer Penguins dataset. So I've never used this dataset. Besides my earlier experience today when I was writing this Jupyter notebook, I had never plotted the data. I didn't know what the features were. I still forget what the features are. I never ran any machine learning tasks on it, so it's still a very new dataset to me. I just learned about it in fall 2021 when my undergraduate and graduate machine learning students started submitting to me projects using this dataset. And apparently it's similar to and a viable alternative to the famous IRIS dataset. And I taught myself machine learning on the IRIS dataset. So that makes me kind of excited to find a new dataset to play around with implementing algorithms from scratch on and just exploring. Apparently, also, it contains 3 different species of penguins, different measurements on these 3 different species. So this is very similar to the IRIS dataset. I haven't seen any videos on YouTube describing it using Julia, and then also penguins are pretty awesome. So I'm looking forward to this video. Let's get started. Before we dive into the code, there are a few requirements I need to mention. First off is that I'm using Jupyter Notebooks as my IDE. This will be how I interact with the Julia programming language. And in order to do that, you need to know how to install the iJulia kernel. If you don't know how to do that, please subscribe to my channel or stay tuned, I suppose, because I'll be posting a video on how to get Jupyter Notebooks set up with Julia shortly. In section 1 of this video, we're going to talk about loading the data and how to inspect the data once it's been placed into a DataFrame type. The packages that we'll need are the Palmer Penguins.jl package, the DataFrames.jl package, and the DataFrames meta.jl package. In section 2, we're going to look at visualizing our data with plots.jl, in particular looking at scatter plots. And as always, another requirement is that if you like my video, please give my YouTube video a like down below. All right, so let's get started by importing the necessary packages to begin with. So using Palmer Penguins, DataFrames, and DataFrames meta. Shift enter. Takes a second to load. Okay, so when we ran this cell, we included into our scope of this notebook all of the functions that are contained in these 3 different packages. One of which came from Palmer Penguins and is called palmerpenguins.load. Okay, so this loading utility will give us access to the data that we need. And we are going to assign that to the variable name penguins. Now, if you're like me and come from a primarily Python background, you might enjoy that throughout this video, I'm going to be including Python equivalent code. So if you would like to follow along in Python, you need to pip install the Palmer Penguins package, and then from that package, import the loading utility and go from there. But this is Julia, so let's go ahead and load this data with Julia. So penguins equals Palmer penguins.load, like that. Shift enter. Now there's a warning here. The first time that you call this loading utility, you may be prompted with an input box to type something into. When you see this, simply type Y, press enter, and then restart your kernel by coming up here, pressing kernel, restart, and clear output. After you do that, everything should work just fine. Okay, so it's loading the data and it's been loaded. It's a mess. This is a bunch of commas, quotes, stuff. Let's go ahead and look at the type of this data using the built-in Julia type of function. Okay, so it's a CSV file type, which apparently is supported by the tables.jl interface. And anytime you have a type supported by this interface, you can convert it into a data frame. Again, when we ran the cell using data frames, we imported all of the functions into our scope. We can use them. And one of the functions that we imported was this thing called DataFrame. This will convert our table of type csv.file into a Julia DataFrame object. So let's go ahead and verify that that's the case. So penguins equals DataFrame, throw in as an argument penguins, and then let's check the type after we do this. And indeed, it is a data frame. Okay. So we should probably look at the data frame now. If I add in a cell right here and just type penguins, we can see it. But it's going to be really big. It's going to be bigger than can fit on my screen, right? So, and we see there's like trailing off dots here. So we might want to look at specific rows or specific rows and columns. And that's what we'll be doing from here on out. So to view the first 10 rows, we can call the function first. We pass in our data frame and then pass in the number of rows we want to see that appear first. In Python, this is equivalent to calling the method .head and then passing in 10. So let's see what happens when we do this. So first, penguins, throw in a 10. All right, there we go. So we see 1, 2, 3, 4, all the way down to 10. So the first 10 columns, first 10 rows of our data is now shown to us. In a similar fashion, we might want to look at the last rows of our data frame. And we can access this using the last function, which is equivalent to the .tail method in Python. So if we want to look at the last 3 rows, just do last, throw in our data frame, penguins, and then 3. Okay. So because this data set is probably new to you, new to me, we should probably look at descriptive statistics, measures of centrality. And one way to do that in a really quick way is to call the describe function. And this is equivalent in Python to the .describe method in pandas. So using the describe function, let's see, describe, then throw in our data frame. Okay, so we can see we get a little table here where this column is the variable name. We have mean, min, median, max. So the variable names are like the column names of our data frame. So we have a species column, island column, bill length, so forth and so on. We have the mean when we can actually calculate it, the min when we can calculate it, median when we can calculate it, so forth and so on. Okay, and then we also see a missing number of missing. We see it seems like we're missing some data. So maybe if I scroll up here, oh yeah, this row has missing data. So we'll take care of that in a bit. So next up, we might want to know the size of our data frame. So data frames are rectangular objects. There's a number of rows and a number of columns. And the way that we can access that information is by calling the size function. This is akin to, in Python, calling the .shape attribute of a given data frame. So let's go ahead and unpack this size function because it returns a tuple and say rows, I'll say maybe num rows, num columns is equal to size of penguins. And then I put a print line statement, pass in a string, the number of rows, do some string interpolation here, num rows like that. And then print line number of columns, more string interpolation, so num false. And we see that there's 344 rows and 7 columns. And we can verify this by scrolling up to where we printed out our full data frame. Penguins, so yes, 344 rows and 7 columns. Okay, we're good to go. Okay, so where are we? Oh, those dang missing variables. So because this is a kind of intro data exploration video, we're just going to get rid of those missing rows. So any row that has a missing data value, we're getting rid of it. And the way that we're going to do that with our data frame is by calling the function drop missing. Okay. And this is similar to the drop in a method. But notice what I just did. I had to fix a typo. There's 2 different types of drop missing in Julia. And those familiar with Python will see that there's 2 different drop NAs here. The reason for this is this little operator right here, the bang operator. So to illustrate how this works, I'm going to type drop missing and then throw in penguins. And remember, there's 344 rows, 7 columns. So I'm going to drop missing. And we see, oh, it returns a data frame with 333 rows. So it got rid of all those missing values. But if I look at the penguins data frame, it hasn't changed. There's still 344 rows. So this is something that's common to Julia. You have a function that returns a new object that has gotten rid of the missing values in this case, or you have a function that alters the current thing that you pass in. And that's this bang operator. So whenever you see this bang operator in Julia, it's typically going to be assigned with a function that alters what you input. So now if I do drop missing with a bang operator, okay, and then I check my penguins data set again, see how it's 344 before, I check it now, it's been altered to 333 rows. So that's a thing that we'll be repeating in a lot of these videos that I make. When I call a function and I put the bang operator at the end, it means that it's altering the input. It's not returning something new. And if you're familiar with Python, you'll probably see that that's the case by looking at this code here. Okay, so let's keep on going. Don't need this cell anymore. Oh yeah, let's describe it again after we've dropped the missing values. Yep, number missing is 0 now, so we're good to go and keep on moving. So next, I want to focus on the columns of our data frame. So the columns can be thought of as keys, and each key has an associated key value that points towards a column of the data frame in question. To look at the column names of our data frame, we just pass in our penguins data frame into the function names. So we see that these are all of the column names that are available. Okay, so once we know the column names, we might want to access a column given a name. Okay, and there are a few different ways to do this. There's 5 actually. We can pass into these curly brackets, bang, comma, colon, the column name. We can do dot column name, colon, comma, colon name, bang, comma, string column name, and colon, comma, string column name. Here, it's important to realize that in Julia, when you're dealing with data frames and you open up these brackets, on the first entry, you're dealing with rows, and on the second entry, you're dealing with columns. So bang here means every row. Colon here means every row. And then the second entry that you give it is the column that you wish to run, okay? So let's go ahead and do this, and let's focus in on the flipper length, right? If we come back up here, we see that flipper length in millimeters is one of the columns. So if we do penguins, bang, comma, colon, flipper length underscore mm, we see that we get all of the entries in that column. If we do the dot operator, we can do penguins, what was it? Flipper length, so dot flipper length underscore mm, same data. And if we do penguins colon comma flipper length square mm, same data. And then we can also, instead of doing the colon name, we can do the strings. So we can do penguins bang comma string flipper length underscore mm. And then lastly, with the colon for the rows. So all of those ways, these are all the ways to access the column data from our data frame. All of it, at least, right? I should say, though, that from what I've been reading, this seems to be the preferred way to access columns one at a time in Julia. Bang, comma, colon, your column name. And then on the fly, when you need the information quickly and need to save space, do the dot operator. Okay. So if we want to access multiple columns, it's the same format, just now, instead of passing a single column name, we pass a list of column names. And this list can be in any of the above formats. And the way that we access the rows can also be in any of the above formats. But again, as I just mentioned, bang, comma, column names with the colon seems to be the prevalent way in Julia. So that's the way I'm going to follow. So what are the names? Because I already forgot them. Names, penguins. So those are my options. I'm going to select 3 of them. Penguins, bang, comma, pass in a list. Maybe fill length, flipper length, and then species. So we see that that's selected every single row in each of those columns. Next up are rows. So many times we're going to want to select a subset of rows from our data frame according to some entry in that row satisfying a given condition. And the way that we're going to do this is by using the macro at subset, which is a function that was imported when we typed using DataFrame's meta earlier. And here is the exact syntax. So we call the macro and then pass in our data frame. And then we want to check which rows are in either one of these entries. I don't know why it keeps on doing that. And then dot the column that we're interested in. All right, so if we're looking at maybe like the species, we want to select 2 out of the 3 species. We should first know what species we have. So one way to look at the unique entries in the species column is to make a set out of that column. So let's see what happens when we do that. Set penguins dot species. So what this does is we have a column of a bunch of different species names. There's a bunch of different entries. We convert it to a set, and sets don't have repeating values, so it whittles it down to the unique values in there. So I see that there's 3. So if I call, I don't know why I have that there, the @subset macro, pass in my data frame, and I'm going to check to be one of these 2 species. All right, let's see what happens. So we get all the rows where the species column entry is either a deli, I think that's the right way to say it, or Gentoo. All right. So that's how we access according to a containment operator. But what if we just want to access a single index, right? And if we look at our data frame as output here, we see these bold black letters. These are the row index for each of these rows. So if we'd like to access the ith row, we just pass that in as the first argument inside of the brackets here. And this is akin in Python to the iloc method. So if we do penguins, first row, all columns, so penguins, first row, all columns. Yep. Penguins. And there we have all of the column entries for that first row. Now, if we want to view a range of rows in a data frame, we can do what's called data frame slicing. So instead of passing in as our first argument a single number, we can pass in a integer colon another integer, and it will get every single entry from A to B at step length of 1. So let's say we have penguins and we want to look at the first 10 rows, 1:10, every single column, like that. And again, we can combine the column and row methods that we've been looking at together. So for example, if we wanted the first 10 rows and only wanted to focus on bill length and bill depth, we could pass into the second argument a array of bill length and m, and then bill depth, like that. Okay, first 10 rows, only looking at these columns. So it's really nice to be able to index through, slice through, call the columns we want, and just get the data we want to inspect. Okay, so that will be the end of part 1, the penguins data set. In the next video, we're going to be looking at plotting this data. Thank you for watching, and I'll see you next time.